to do a review. I'm going to do this with the class. So I'm going to record it and you can follow along and get points for turning this in and showing me that you did it. All right. So the first thing is we are going to be having a quiz tomorrow over this stuff. So this is all section 1 through 4. So we learned about 2 different kind of reactions in this chapter, or so far in this chapter. We'll have 4 altogether, and here's the first 2. We learned about hydrogenation, which when you see that term hydrogenation right away, I think hydrogen, and that's what we're doing. So on hydrogenation, we're going to draw this out. So I have hexene, so hex is 6. So I'm going to draw this structure out. And I see that after carbon 2, I have a double bond. Now I'm going to go ahead and add my hydrogens. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I'm just making sure each carbon has its 4 bonds around it, and each line represents a bond, so it needs 4 lines around it. Now then, with hydrogenation, you're adding hydrogen. So I'm going to add H2. I drew this in a different color so I could show you what I'm getting ready to do. So what this hydrogen, this H2 does is it comes and it breaks up that double bond, and then there's each of those hydrogens. So when you rewrite this, 1, 2, 3, 4, 5, 6. So I left those 2 blank because I'm showing you where those 2 hydrogens went, right there. So now you went from 2-hexene to just hexane. Now you can do this with a triple bond also, so you can, it's just breaking up bonds. Now if I would have put a 2 here, I would have been able to break up 2 bonds. So if I had a triple bond, that would have worked for that. But anyways, let's move on down. So we're going to look at how the combustion is a little bit different. All right, so combustion reaction for, we want octane gas. So octane gas is C. Now this time I am not going to write this thing out. I'm just going to write how many carbons and how many hydrogens I have. So octane is 8. Hydrogens. Now to figure out my hydrogen number, I'm going to do this. So I'm going to do 2, 8 squared. So 2 times 8, 8 squared is, that's not right. No, what is 8 squared? Let me see, something's not adding up right here, so let me do my carbons. No, let me do it over here. Okay, I know. I was like, where that squared is going to make that number really, really high, higher than it should be. So what I'm going to do here is 2. I've got 8 carbons plus 2. So 2 times 8 is 16. 16 plus 2 is 18. Sorry about that. Kind of, my brain went blank there for a second. All right. So that's the quick way right here. This right here is the quick way to figure out this number of hydrogens. You can do what I did and just draw them out and figure out how many hydrogens there are, but it's going to take you a little bit more time and some space on your paper. All right, so in a combustion, anytime we have flame or fire, we have to have oxygen gas. Now what we get, so if I were to light a piece of paper on fire, what I'm getting from that, and you would see some smoke, is some carbon dioxide gas, which is why we don't survive in smoke, because we need oxygen. Plus we get some water vapor, which seems weird because it's on fire, but we are getting some water vapor out of that. And then of course you get some energy, so I'll just put plus E, that's the energy we're getting out of it. Okay, so I go through this very methodically, step by step. So what I look at first is I look at my number of hydrogens, and I see there are 18 here. So I could put a 9, I'm going to write it right here, 9 here to get 18 hydrogens. The problem is if I have an odd number right here, 9, that would give me 9 oxygens. I can never have an odd number of oxygens right there. So if I ever get an odd number of hydrogens here, I have to double it. So I'm going to go from 9 and I'm going to go to 18. So now I have 36 hydrogens. So I'm going to have to put a 2 here. All right, now that I have my hydrogens balanced, I'm going to do my carbons. And I have 16 carbons now. So I'm going to have a 16 here. Now the reason I leave my oxygens for last is because, look, I can put something here without it messing up any other element. All right, so right now I have 18 and 32. I have 50 oxygens all together on this side. So I can put a 25 here. You can get some really crazy numbers with these combustion reactions. So that is how you can do that step by step and balance that. It normally takes kids a very long time to try to figure this out when they don't do like hydrogen first, carbon, then oxygen. If they just try to start messing with it, usually takes them a little bit. All right. Let's go down now. Those are our 2 reactions. Those will be, you'll see those tomorrow. It says write the formula for 2,2-dimethyl 4-propyl heptane. Use the correct number of hydrogens. I'm going to be very big on that here from here on out. How many hydrogens are there? So I have, and I do it. I can blame myself for this too. I have a lot of kids that will do this, and they'll be like, "There's my structure," and they're not putting those hydrogens on there. So I want to make sure that we do know what those are. So the first step I do here is I look at my longest chain, heptane. So I'm going to go ahead and draw my 7 carbons for my heptane. Then I'm going to go back and add the branches. So I know on carbon 2, I have a dimethyl, so C. Now something I see kids doing a lot is not putting, or just putting 2-dimethyl. They're not doing the 2,2-dimethyl. You've got to tell me that both of those methyl groups are on carbon 2, so you have to put both of those 2s. Now 1, 2, 3, 4. On 4 I've got a propyl. I'm going to have to draw it this way, which is fine. You don't have to have it going straight up. And then heptane. So now I'm going to go back and I'm going to add my hydrogens to this. I'm going to do those in red so we can see them. There's 1, 2, 3, and of course there's that 4th. This carbon, the second carbon is already good, but look at these guys. They need 4. This one needs 4. 1, 2, 3, 4. Oh, that's going to, oh no, how do I get that back? I don't know if I can get that back or not. I can't. All right, well, oh my goodness, I don't know what just happened. 1, 2, all right, I'm going to have to draw it. I don't know what happened there, I'm sorry. So let's draw my 7 again. I'm going to do this quickly since that just happened to us. I'm going to put my propyl down here. Not on 3 though, it should be on 4. Okay, now I'm going to go back and draw in my hydrogens. 1, 2, 3, 4. These guys have theirs. This right here. This one just needs 1. 1, 2, 1, 2, 1, 2, 3. But look, there's these guys too. Alright, so I could write this. Another way for me to write this would be to write this as, looking at this one, CH3, C, CH3, CH3, CH2, CH, CH2, CH2, CH3, CH2, CH2, and CH3. Alright, so some students by the end of this chapter, they get to where they know how many hydrogens there are going to be and they just start writing it like that. I will begin to do that. As I get you guys kind of used to this, you will see me start to write them like that. All right. So anyways, this is how you write that one with correct number of hydrogens. All right, number 4 says write the formula for 1,4-dibromo 4-methyl 2-pentyne. Use the correct number of hydrogens. So I see pent, so that is going to be 5. Now I see that it is 2-pentyne, which YNE is a triple bond. So there it is. It's after carbon 2, 1, 2, then put it. On carbon 1, I have a bromine. On carbon 4, I have a bromine. And also on carbon 4, I have a methyl group. All right, now I'm going to go back and add my hydrogen. So this is 1, 2. I would need 3, 4. So I would write this as CH2. This carbon right here already has 4. So does this one. This carbon also already has 4, but you notice I already put the CH3 on this one down here. And then right here it would be CH3. All right, so that's how you do. Now, you do not have to do it like that. You can just put the lines. So tomorrow on the quiz, or the quest, I call it a quest, you can just put the lines. You don't have to write CH2, CH3. You can put lines, and that'll be fine with me for right now. All right, let's go on down. Name the following hydrogen-carbon chains. I'm going to give them a chance to try to do these, and then I'll go back through and work these with them. So what I'm going to do is I'm going to use my highlighter here. Let's do the green. I'm going to highlight my longest chain. So just looking here, it's going to be that. That will be my longest chain. Yeah. Okay. So let me go back to my pen now. So my longest chain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be decane. And it's decane. There are no double or triple bonds, so it's A and E. Now I'm going to look here. I've got a methyl, a methyl, a methyl. I'm going to circle I've got an ethyl and an ethyl. And I have 2 propyls here. So let's see here. I could count and go 1, 2, 3, 4, 5, 6, 7. I could go 1, 2, 3, 4, 5, 6, 7. All right. So it's the same either way. So I'm going to go the way that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. If I go this way, 1, 2, 3, 4, 5. I pick up more of these things. There's 1, 2, 3, 4. Than if I go 1, 2, 3, 4, 5. I only pick up 3. So I'm gonna number my chain backwards here. So this, let's go ahead and start numbering or naming this. Ethyl's gonna come first. So that is 5, 7. Diethyl. Okay, so I did those. Now my methyls are going to come next. So I have 4, 4, 4, 4, 1, 2, 3, 4, 5, 6, 7, 7. Trimethyl. Now when I do alphabet, I do not use the T. I'm using that M. And now I'm going to do my propyls. It is 5, 6. Dipropyl. And then you can put the ending, decane. Now this is a hard one. Like this is one I think that would probably be an extra credit type. So, yeah, this one's kind of a more advanced one. Okay, I'm going to clear that out. You can always pause it or go back if you need to see it. Number 6 is more of a simplistic one. I'm just going to go 1, 2, 3, 4, 5, 6, 7. So that's going to be hept. Now there is a double bond, so it is heptene. Now I'm going to go 1, 2, 3, 1, 2, 3, 4. I'm going to go 3. So I'm going to start here as carbon 1, 2, 3, 4, 5, 6, 7. I don't care about where the branches are at that point. If there's a double or triple bond, I am counting my closest way to it, no matter what. Don't care about those branches then. All right, so that's 3 heptene. I have a 5, 5 dimethyl. I made sure that I put this one on here because I have so many kids doing this, 5-dimethyl, and that is it. And I've been just kind of correcting it for them, or maybe taking only a half a point off for all the times that they do it. But tomorrow, that is going to, I'm going to make sure that you're doing that. And then 3-heptene. Make sure you're not forgetting to tell me where that double bond is. All right, so that is that one. If it were a triple bond, it would have been heptine. All right. Let's look at number 7. Number 7, my longest chain. Looks like it's going to be that right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's another 10. So decane, A and E, because there's no double or triple bond. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm going to count once. If it's the same either way, I'm going to go with my alphabet. And so that's going to put this one first. So it's 1, 2, 3, 4, 5. Now these, I put some of these up here like this. I've got some harder ones on here. Because if we can do the harder ones, then we can do the easy ones. All right, so this is going to be 5-ethyl. And then we've got 5, 6, 6, 5, 6, 6, trimethyl, and then you're going to put the ending on here, decane. Okay, so that is the end. Now in class, if we have some extra time, we're going to draw some extra ones and go over those. If there's any questions that you have, or you want me to, or you want to draw one and make sure you know how to do it, or you want me to check it, or anything like that, just let me know. Just send it to me and I'll check it and get back with you. Have a great rest of your day. Bye.